from Robotics, and I will do this training for the next 3 days about the NAO robot program. So basically, my expertise is not in NTE. Okay, you probably know better than me about NTE. My expertise is more about the robot here. So basically, for this training, I will just show you how to program the robot. But then, of course, you need to just apply that to your NTE application. I have already given some keys, some using keys here and there. If you have a computer, you can please give the key to other people, and you can copy everything. There is different materials like the installation software and some the document, the copy I will show you, some different materials that you can copy it on your computer.
I want to remind you, do not install the NAO thing on all your computers of your team member. Remember I mentioned yesterday?
Yeah.
Because the NAO thing license will be expired in 1 month, but you will need this license until the May the 12th. So just install one of the computer, and then after half a month, like April the 15th, install it and in another one. So in your team, you always have the NAO thing license.
Yeah, maybe you don't know your team yet. Maybe Eric, we should discuss more about that, because I think actually the license is linked to this choreograph license. So, and I guess they want to all this stuff choreograph to work on it. But maybe find a solution to give you a temporary license. There is a simulator, yes. We provide a simulator.
Can you install the software on the Windows and share it?
Maybe it's possible. I never tried that, but maybe we can try. Should be okay, I think. Okay, so I will start the training by introducing you the hardware about the robot. So this morning I will introduce you the hardware, and I will also show you what we call monitor. It's one of our software. And this morning I will also show you what we call the NAO web page. This afternoon I will more discuss about choreograph, which is our programming environment. It's a visual programming environment. And then tomorrow morning, I will introduce you some C++ programming. And in the afternoon, I can answer some questions and do some exercise. And the last day is fully a kind of workshop, so you can try, practice, and can answer your questions. So let's start by the sensor and actuator on the robot, and then I will also give you some best practices. However, for you, maybe it's not very critical because you will only have one robot for all the team. So you will mainly work on the simulator. But this best practices is just to avoid breaking the robot. So for the sensor and actuator, we have, that's a brief summary, we have some joints, some LEDs, one initial board, some sonar, 4 or 8 FSR, which means also sensor resistor. That's good. I will detail all of them later. some switch, some button, and capacitive also. And you have infrared emitter and receiver, 2 cameras, and 4 microphones, and finally 2 loudspeakers. For most of these sensors, you can have set value every 10 milliseconds. Mainly for the sonar is for 100 milliseconds. So let's start by the easiest one, the switch and capacitive. So you have, of course, you have the chest button here. So this button is used to switch on the robot, switch off the robot, and also to get its IP address. You press one time. You have also a foot bumper here. So there is 2 contactors per foot. So in total it makes 4 contacts. We have 3 capacitive area on top of the head, so 1, 2, and 3. And we also have 3 capacitive area for each hand, which are here, on top, and here. So 3 for the right hand and 3 for the left hand. So the switch and capacitive is just binary values, 0 or 1, it's pressed or not pressed, touch or not touch. For the LEDs, we have 8 sections of RGB LEDs in the eyes. So RGB means full color, you can set any kind of color. We have 10 blue LEDs for each ear, so it's only blue, but you can change the intensity. So 10 here and 10 here. We have 1 RGB LED for the chest button. So the robot uses the color to indicate the battery level, but you can override this and set the color if you want. We also have 1 RGB LED for each foot here. And finally, I forgot to mention the 12 blue LEDs around the skull cap. So the value, like I said, you can change the intensity from 0 to 1 for all the LEDs. So I will demonstrate this switch button with a graph. Monitor, sorry. So monitor is a kind of debugging tool. This is just a simple software to monitor different values on the robot, different sensor or the joint position or anything. It's a very simple software. There's only 2 buttons mainly here and there, which are the same as this menu here. So I click on the graph button first. Then I need to connect to the robot. And after connecting to the robot, you have this window appearing. So here the robot is connected in Wi-Fi to the router, which is here on my desk. And my PC is also connected to this router. So of course, when you want to connect to the robot, you need to be, your computer and the robot should be in the same network. So in this window, you can create a new configuration file or open a configuration file. So what is that? Because actually, monitor can monitor many values, a lot of values. So if you just want to look at some of them, you can choose the one you want to look at, and then you can save this as a configuration show you. If I click new configuration file, you can see that you have some values you can monitor, and if you click view device, you even have more values that you can monitor. So the idea is, for example, you choose this one, and when you click OK, you can save this XML file on your computer. So later you can reopen it. You don't need to choose them again. I will not do that because I already have a configuration file. Connect again, and I choose open configuration file. So I take the food buffer. And monitor is basically split in two window panes. So on the left you have the list of all the value you want to monitor, and on the right you have a graph. So that means the value will be displayed along the time. Here you have an auto scale, so you can send it or check it or uncheck it. If you check it, then the graph will automatically scale between the minimum and the maximum value. Otherwise, you can specify it. So if you want to see the value, you should also click the graph. Yeah. So watch. If you just select watch the graph, the value will be displayed here on this column. And if you check the graph, it will also be displayed in the graph pane. Of course, you can also choose a graph all, or if you want to check all of them. So now if I press the foot bumper, I can see that it's switching from 0 to 1. And over there you have the different color. So basically the first one is the right foot, then the two other is left foot. So right is in yellow, and the right foot left is the blue one. Okay, so, and of course if I press in the middle, both will be triggered. And that's the same for the other foot. And here, for example, you can see that the colors are very similar, but you can change the color if you click on the color. You can choose another color, for example. And then it's better to see the difference. So basically, this is how it's working monitor. And this is a useful tool to check if everything is fine on the robot. I don't know if you have noticed, but when I click on one button, I first need to connect to robot. So you don't have a robot, you will have a simulation, but you can also connect a monitor to your simulated robot. In that case, you can just type the localhost address here, 7.1, to run your simulator on your computer. So the next job very important for a robot. The joint actuator, so basically all the motors, now has 25 motors, 25 degrees of freedom. And for every motor you can set or get the value, the angle in radians. So you just control the motor by setting which angle you want for each joint. And to get the angle, we use what we call MRE. I don't know if you know what is MRE. MRE means magnetic rotary encoder, and it's basically a chip with all effect sensor. So means something to you. But basically, to make it simple, you have a magnet stick to the motor, and you have a chip in front of the magnet, and the chip can detect the magnetic field. So when the motor is turning, the magnet is turning, so the magnetic field is also turning. So the chip can detect the movement. So it's a very precise detector, sensor, has less than 0.1 degrees of precision. It's of course absolute value, it's not relative, so you don't have derivation over the time. And it has very low noise. So you have one MRE for every joint, and you even have 2 MRE per joint on the bottom part of the robot. One directly on the motor and one after the gearbox. You can also get, for every motor, you can also get the electric current sent to the motor, so in ampere. And you can also get the temperature in degrees Celsius. But the temperature is a simulated temperature. That means there is no real temperature sensor on the robot. It's just an algorithm that computes what is the temperature of the motor based on how many current is sent over the time, and the physical model of the motor. And you can also get and set what we call the stiffness. So the stiffness is how strong is the joint. So currently the stiffness is new, that means I can move my robot. And of course if you ask him to stand, it will fall. But if you put the stiffness, then the robot will become more strong, and we try to resist to keep its position. So 0 is no stiffness, 1 is the maximum stiffness. And we also have some algorithm in the robot, which we call smart stiffness, which automatically compute what is the best value for the stiffness to first avoid the motor to get hot too quickly, and also to save the battery situation. So let's look at that. The monitor. I connect again to my robot. And this time I will open the right shoulder pitch configuration line. First, I will graph the 2 positions. So basically, I'm looking at the angle of the right shoulder pitch. So when I move it from network live. Yeah, when you move it, you can see the position, the angle, changing in radians. I can also look at the stiffness and the current. So graph these two, and I will also watch the temperature of the motor. But to do that, I need to put the stiffness on the robot. So I will do that with the graph right now. I will explain it in the worry. So here I just put the maximum stiffness, but like I told you, there is this smart stiffness. So now the robot is more stiff, which means I can hold it like that. And in red, you have hardness or stiffness as the same, which is currently around 0.3, 30% or let's say 70%. And in yellow, you have the electric current, which is quite real. Why? Because the robot doesn't need to send some current to the motor to keep this position. But if I force on the joint, on the articulation, you will see that the stiffness will increase and the current will also increase. You can force it gently on it, and of course the robot is sending more current to try to resist this. And if I continue to do that, the temperature of the motor is increasing. Now it's 42. It's 43, right? So yes, this is the stiffness and the current for the joint. I can do stiffness. Any questions so far? So the next sensor is the inertial board. So we have an inertial board located here under the belly of the robot. And in this board you have a 3-axis accelerometer and a 2-axis gyrometer. So the 3-axis accelerometer gives you an acceleration, linear acceleration, and the gyrometer gives you a rotation speed. And we also compute on board the current inclination of the robot, the current inclination angle of the robot. So let's look at that in the detail. First, I will graph the accelerometer. We'll go 3 acceleration, x, y, z, and the axes are like that. So the x is in front of the robot, the y on the side, and z up. So you can notice that the Z accelerometer, the X and Y are almost nil, but the Z has a negative value because the robot is detecting the Earth's gravity. Of course, if I look at the robot like that, the two curves are crossing, and now it's the X, blue X value that detects the Earth's gravity. If I rotate it like that, then it becomes the red and white axis that detects the Earth's gravity. Of course, I can detect an acceleration. That is, if I move it like that, it will detect the acceleration like that. The red one and the green one is up and down. I can also graph now the gyrometer. So the gyrometer, you have the Y rotation like that, and we also have the X rotation. So if I move it like that, we want the rotation, and if I move it like that, it's the red curve detecting, but we don't have this rotation. We don't have along the Z-axis. So that's the speed, the rotation speed, which means if after the rotation is finished, then the curves return to 0, because it only detects the rotation at the moment of the speed. And we also have, like I told you, the angle. So the angle, this time detect the current angle of the robot. So if I limit it like that, it will keep the same angle. So if I limit it like that, you can go back to 0 here. Okay, so there's a difference between the angle and the rotation speed.
Relatively standing.
Yes. Standing is 0. Almost. I'm moving, but basically yes. But the curve is also scaling, so it can be confusing. So basically the sensor, the initial bound sensor, you can use it to detect if the robot has fallen, or if it's lying down on which side, if it's lying on the belly or on the back. Just by checking the angle, or you can check also the Earth's gravity. The next sensor are the FSR. So FSR means force sensor resistor, and this is a pressure sensor. Okay, so it detects how much pressure you have. They are located under the foot here. So they are located under this little hole here. 1, 2, 3, and 4. So you have 4 sensors per foot, which means the robot can detect if his bone height is more in front, or more in the back, or more on the side, or on the side. So we also give what we call the center of pressure for each foot. So depending on it's the barycenter of the 4 sensor actually. So you can check where this one is going, and if this one is going very far out of the foot, you may fall, of course. So the value, you can get the direct value from the sensor, the raw data, or you can also get the value in kilograms. So let's check it in monitor. Connect to the robot. course, if I press somewhere else, all the four values will have different, all the four sensors will have different values. So I can also graph the center of pressure. So that's basically the middle. So if I move up, it will be the x value, the red one will change. For example, x negative, and then move up and positive. And I can also move left and right. So this one is two value which is any questions so far? Yes.
Is there a formula for the balancing, or we have to figure that out? In terms of the X, Y?
I think you have to figure out by yourself, yes. If you want to make a closed loop algorithm, you have to figure it by yourself. But I would say, for your project, I don't think you need to research on that field. For you, it's more application about LTE, so I think it's much higher programming, not low-level motion programming. You have researchers that they only want to improve the balance of the robot or make him walk fast. And of course, they will use this kind of sensor and control all the joint motion, but it's complex. You need to have the whole kinematic of the robot. So for you, I think you don't need, we provide, or you just have to provide the walk, so the robot can walk, but with a very simple interface. You can tell it to go this way, that way, and it will manage which step, how to move the step, and that's enough for you to just go that way. But I still show you that because, I don't know, maybe you can have a simple behavior just by checking the pressure. For example, a very simple behavior, if someone catch the robot, pick up the robot, and suddenly no pressure on the foot. So just by checking that, you know that the human pick up the robot. And you can make the robot react and say, oh, that's kind to take me up or put me down, I'm afraid, or whatever. So this kind of sensor can be used like that. It really depends on how many time you want to spend on programming the robot. So this is, for example, how the barycenter is moving when the robot is walking. So the robot is walking in that direction, and it's moving left and right. That's just an example of doing the walk. That's a quite old data, actually. So the next sensor is the sonar. So the sonar are located on the chest. So here on top is the emitter, on bottom is the receiver. So you have two emitters to receiver. So one for the right side and one for the left side. So you can get, we provide multiple echoes up to 10 every 100 milliseconds. And when you use the sonar, take care of the arms, which means you should put the arm like that in front of the robot, and the sonar will be locked. So you should put the arm along the body to use the sonar. The sonar is not started automatically when the robot boots, for two reasons. First, to save the battery, because not many people use sonar. And also because it's making some little crackling noise, very little. So if you want to use sonar, you just need to start them from the API. So maybe I can try to demonstrate the sonar. The sonar is usually a very noisy sensor. I don't know if you know that. This is just a kind of limitation of the technology. So it's not very often, it's not very easy to see something, but I will try. So we provide multiple echoes for left and right, and for left and right. But I will just graph two of them, that's enough. And like I told you, I need to stop them. I can do it with the graph. Okay. The robot. So it gives you normally a distance in meter. And if I move it, okay, the distance is increasing. Well, after you have the auto scale, so it's really easy to see that let's use a fixed scale. So the sonar can walk between 25 centimeters to 2 meters maximum, 2 meters, 40.5 meters. So here we are around 1.5 meter. I don't have a ruler, but it's probably quite correct. I can increase a little more, I think. And when I go back, I will go to 0.25, which is the minimum. Even if I'm closer, actually. Okay, yeah, I am at 10 centimeters from the wall, but it's still give it to 0.25. You can also, if I rotate the robot a bit like that, then, or maybe I rotate too much, then you can see that the red curve is the left, is above the green one, because of course the left, the distance is bigger than the right. And if I rotate, the two curves cross here, and then now it's the blue one, which is bigger. So the sonar is working quite well for the wall, for example, or a flat surface, because the wave can bounce easily and nicely on the wall. If you have a very strange object like that, you will have different echoes, so you will have a lot of noises, of course. So usually when you use the sonar, it's better to use some kind of filter. You filter the data, and maybe along the time or something like that. Otherwise, it's working quite well with the flat wall. For example, this one has a slope, so I guess maybe it will bounce maybe not so well. So it really depends on the environment. But this can be useful to make a very simple navigation and to avoid to bump into the wall. So basically, if you can detect the distance on the right is closer than the distance on the left, and you can make the rower turn to the left, because you know that the wall is something like that, so it's moving toward the wall, so you can just let it walk away. And same thing in this line. That's why it's good to have two sonar, left and right. That's an example of different sonar detection. Okay, the next sensor, also very important sensor, is the camera. So it has two cameras. Oh, actually, I'm sorry, this one is not up to date. I should not show this document. Okay, so here is the new camera, sorry. So we have two HD camera, which are located, one here on the forehead and one in the mouth. And the two field of view are crossing at 40 centimeters, which means when NAO is stand up, you can see everything. The two cameras cover everything in front of him, from his foot, really from here to maybe quite far. And the two cameras can work at the same time, so you can get two at the same time. And the size, the resolution is 1,280 by 906 pixels at the different passages. But the stream is not compressed. It's a raw data. It's a raw data. Why? Because usually people who make this vision algorithm, they prefer to have the raw data, just to work on each pixel, and don't have artifact with compression. So of course, this is quite a huge data, very huge data, and it cannot go through our Wi-Fi network or even the Ethernet. It's quite big. But in LTE, it would be possible to fully stream the whole data. But again, the router doesn't have LTE yet. We are working on that, to maybe integrate LTE in that format. But for now, it's not finalized. So that's why you have this. You have this resolution at this frame rate, NAO. So it's for people who want to make vision algorithm running inside the NAO's head. But you can also decrease the resolution, and at the lower resolution you can also have a decent frame rate if you stream the video on your PC. So I will show you that. So this time I click the camera button, and it's a different plugin for monitor. So this time there is also two panels, but just some settings for the camera and feedback here. So I should press the play button to get the feedback. I can increase the frame rate normally. It's not crashing. Yeah. Okay. And I can change also the resolution. So in Wi-Fi it's still quite slow. Frame rate is decent, probably yeah, around 10. Yeah. So you have some settings. You can change like the camera in black and white. You can also have some mark detection. So the mark detection is mark here. Sorry. Mark detection is we provide some specific mark. I'll show you. And you can print them. You print them, and then so it's like that. Okay. It's kind of circular mark. It's different sectors. So you can print them, and if you show them to the NAO, it will tell you this number, the number associated with the mark. And this is quite fast, quite reliable. And we provide the algorithm, so you have nothing to do. So it's quite fast if you want to put some marks in the environment of NAO. That's quite useful. So I don't know if you want now to bring something to a specific place, you can put a mark on that place. Yes.
Are we limited to those marks?
We provide 10. We provide 10 different marks you can print, and yes, you are limited to these 10 marks. And we don't provide the software to create them. Why we provide this 10 mark is because this is the 10 best mark, because the mark which give the best result. So I cannot. So if you check the mark detection and you show the mark, it will put on screen if you detect it. I cannot really show you because it's usually brings some kind of visual Larsen effect if I do it. But I can try, but I'm not sure. It usually brings some Larsen effect on screen. Let's try it. That's the kind of Larsen effect. And normally you can detect silver mark on the substrate. And it can also work if the mark is not straight and you measure the distance also. Okay, the measure the distance. Well, there is a limit, of course. If there is not enough pixels, it becomes a bit short. We detect the ball. And of course, if you maybe the resolution of the camera is not great also here. But basically, that's the mark detection. You can also use it to control now, just by showing some cards. Quite quickly. You also have the face detection. So normally this one just put across on my nose. Look at it. It depends on the lighting condition also. It can detect multiple faces at the same time, up to 5, I think. I'm not sure if you detect increase the resolution a little bit. So detect 3 moves, making a little bit. Of course, if you look more in front, it's better than on the side. That's the face detection. We also have what we call vision recognition. So for this one, you need to learn to teach now some object, and you need to teach you how to recognize the object, and then you can recognize them. I will show you that this afternoon. You can do that with programming. But here I think there is no object in the database of now. We can of course select the bottom camera. And after that some classical explanation, brightness, balance, which you can change. In this panel you can also record a video of the camera. So basically this one is quite useful if you want to make a vision algorithm, because if you want to debug your algorithm, you can record a video and then you can replay the same video and feed the same video to your algorithm. So you give a name, you press the record button, hello, and then you press stop. You can download it. So the video is recorded on NAO, on the head of NAO. And then it is downloaded to the network to your computer. So I need to connect to the robot to download it.
Audio already.
No, it's only the video here. And I'm playing the video on my computer. So that's it basically for the video plugin and what you can check with this monitor. I'm telling you the vision recognition is quite useful if you, if you in your project you want to have now recognize some object. If you want to debug, test your algorithm, you can go to the monitor and when you see it, show it.
For example, streaming the video directly to the outside instead of using this.
Yes, of course, this is just a tool, so it's basically closed. It's just a tool that doing the stream. But yes, you probably want to do your own stream. For that, use the API we provide. But for that, you probably need to program in C++ to do this. And also a lot of network programming, I guess. And Yeah, so for you, you are supposed to imagine that you have LTE in the robot and stream through the LTE, but you currently don't have Wi-Fi, so you can just program it through Wi-Fi. Okay, so after that we have after that we have the microphone, so and the speakers. So two speaker, quite big speaker here, so you have quite good sound. And four microphones, which are located here, on front, and here, here, and back is here. So with these four microphones around the head, you can make sound localization. And actually we provide the sound localization. So you just need to use it, you can just use it. And with the sound localization, you can like now react to any noise. So for example, you can rotate your head in the direction of the noise, or you can even walk in that direction. You can call. And you can, of course, record one channel, the front channel, or four channel if you want. So and the speaker you can play MP3 or WAV file or a different format. That's it for the hardware. I have to tell you everything about the hardware of NAO. Just a few words about some best practices. So to avoid now the floor, you need some space. So that's why you have a great space here. The surface is quite good. Well, this one is also quite good. Usually nowadays some kind of sleepy surface, but not too sleepy. Okay. Carpet, it can work on carpet, but depending on the thickness of the carpet, you have more or less good results. Because for walk, it used FSR, the pressure of the foot. So if the carpet is quite thick, maybe the pressure is not very even on the sensor. So the NAO is trying to compensate, and it has this kind of strange walk. So it's better to have now walking on a hard surface. You have better result. Like the tile, or like the wooden floor, or that kind of floor. Or if the carpet is quite okay. But also, when you move, it's better to do it on the floor, because be careful do not fall down from the table. Okay, if the robot falls down from the table, it may break something. If the robot falls from its own height, usually it's okay, it doesn't break itself, but not from the table. Also, be careful about the different cables. So you have the Aurora charger here, the plug. You may have the Ethernet plug here. So when you make some demo, when you test your program, it's better to remove the plug if it needs to move. Otherwise, the Ethernet plug can pull his head behind and make him fall, or even that. Also be careful when you lie down the robot on the table, if you have if you have a Ethernet plug like that, and if you want to ride on the robot, if you do that, you will definitely break the cable. Not really the robot, but more the cable. So you can turn the head like that. Or it's better to always work with Wi-Fi. Okay, you just need to set up the Wi-Fi one time, and it's saving the robot. So After that, every time you put the robot, you can remember the configuration and connect again to the Wi-Fi, unless you change the password. Also, for the motor, if you say now it says something like joint temperature is hot, so you can cut the stiffness for a while and let the motor cool down. We have less of, not so much this kind of wiring, but sometimes it can happen. And also some very good practice about the chest, but so you have, if you press one time, now we'll say it's IPRS, that.
Hello, I'm Marvel. My internet address is 194, 168, 102. My battery is strong.
And if you press 2 times, like that,
Stiffness removed.
then it removes the stiffness. You get the stiffness. So if your robot becomes crazy or whatever, strange animation, you can just double press, so it doesn't have the stiffness and will stop moving. And you also can use the chest button to switch off the robot, of course. So if you press for 5 seconds, it will make a normal shutdown. If you press for 9 seconds, it's hardware shutdown. So that's it for the hardware. Do you have any questions? No? So the next thing I will talk about is the NAO web page. And the bit first. So, so this morning I told you I will talk about hardware and then NAO web page. This afternoon we talk about program. Thank you very much. So, like I just showed you, you just press one time and it gives you this IP address. Once you have the IP address, you can just type the IP address in your web browser. So then you have to log in on the robot. So to do that, you type the login and password, which is NAO. It's the same. NAO, NAO, and NAO. And then you enter into this web page. So currently, I am browsing this web page inside the head of NAO. I didn't tell you, I forgot. In NAO, it's Linux running. So we have Linux Gen 2 distribution. Do you know Linux? Who is familiar with Linux? Raise your hand. Well, not so bad. Not so bad. So Gen 2 inside. Yes, you are browsing this web page. The first page, the About page, can show you the current software version. So currently it's 1.2. The current language, the battery level, and the internet, the IP address. So currently only connected with Wi-Fi, there is no Ethernet cable. The second page is the network page. If you click on it, the robot will list all the Wi-Fi network that it can detect. So currently I have connected to this one, this NAO. Wi-Fi here. And so if you want to connect to Wi-Fi network, just need to click on it, and then you can click the connect button. Yeah, and then you connect it to it. So, for example, I can choose another one like this and make it connect. And if there is a password, then you will prompt for the password. That's quite easy. You can also set a static IP if you want. If you choose this one, you can enter the IP address. So that's for setting the network, and like I told you, these settings are saved in the robot, so every time you boot the robot, you can connect to the Wi-Fi if the motor is on. You can also delete some settings by clicking the forget button. If you don't want to connect anymore to that Wi-Fi router, you can click forget. The next page, the setting page. There are some settings you can adjust on your robot. So the first thing is the name. You can change your name. Well, that's quite useful if there is many robots in the same laboratory. Yeah, you will only have one. It's not very useful for you. You can change also the icon that is visible when you try to connect to the robot. You can choose the default language on the robot. But for that, you need to have installed the language package on the robot. So here on this robot, I have installed many language package, so I can have many choice. And you can set the time zone, set the volume, and the next one is quite important, the phone manager reflex. So basically, I will try to demonstrate it. Not sure it will work, we'll see. Or maybe I should make it work a little bit. So that's the phone manager. Yes, I'm going to ask you master. Basically, if you check this, it will not try to protect itself. Here, he tried to protect itself by cutting the stiffness and putting his hand like that. So basically, his hand like that or like that, it depends, to avoid it to break. But if you check this, option, then you can disable phone manager programmatically. So if you don't want to have your robot in a dangerous situation, you can just leave it like that. So that's why if you check it, you have actually a warning that explains you that you are taking risk with your robot, and say, okay, I understand the risk, I really want to deactivate the phone manager. So why that? Because some users, they really don't want to have the phone manager activated. Some users may want the robot to fall intentionally. It's, for example, a good example is the robot keeper. People who are making robot keep with the robot and have the dolly, and they want the dolly to jump. So they make the dolly jump, but they don't want the robot to protect itself from the dolly is jumping. The last one is remote control. This one maybe could be quite interesting to demonstrate and have done, I think. So, oh yeah, I forgot to mention the infrared, so the hardware. Should have a slide for that. So you have infrared, they are located in the eyes. So you can control now with a remote control, or you can have now a controlling device, like a TV, or like the air conditioning, or whatsoever. But to do that, you need to have, you need to first record your remote control. And it's in advanced page. So jump directly to that. Advanced remote control. We will see the other advanced page. So first you need to give a name. We'll take this one. You can get a name in Epson. This is the name. Or you can name it, I don't know, video projector. And then, so it's working only with remote control that implement the LIRC protocol. LIRC, it's open source protocol for infrared. Okay, so I'm not sure if this controller use LIRC, maybe not. So we will start, and the problem is I don't need to control it. I don't want to control the video projector. I'm pressing all the buttons. It's usually quite long to do. I have no up since I have success. So once it has recognized the remote control, you can record some keys. For example, I will try to record up and down. So I will, okay, down key, I press record. I am pressing the down key on the, yeah, working, not sure. Doesn't like my down key. Let's try another one. Anyway, it's not very great. It really depends on the remote control, but you can finally succeed it. And basically, after you have recorded some remote control, you see them here, so you can enable or disable this remote control. Press the save button. So why? Basically, it's because you can record several remote control, but they all use the same protocol. Maybe one key on one remote require another key on another remote, so you can have confusion like that. So you can just record several ones, but just enable some of them. The next advanced page is, so that's it for settings. You have seen all the major settings. The next advanced page is NAO-Chi, advanced NAO-Chi. So in this page you have, first you have 3 buttons to start, stop, restart NAO-Chi. So what is NAO-Chi? We will see what is NAO-Chi tomorrow morning. NAO-Chi is the main program running on the robot. So as you know, there is Linux inside, but Linux is just the OS. And we have main program to handle all the sensor and actuator of the robot, and we call it NAO. So from this page you can click the restart button, for example, just to restart it. And it should restart. And the robot says Onyak look when now she starts. So I'm surprised it didn't restart. So finally started. So basically this page is useful if, for example, now she crashed. So if you have implemented some nasty behavior, stack overflow or infinite loop or whatever, and you stuck Naochi, you can just stop it and restart it from this page without rebooting the whole robot, without rebooting the rest. On this page, you can also see all the modules installed on the robot and all the behavior installed on the robot. So the modules, what we call a module, is basically a library. Okay, a module is a collection of methods, basically like a DLL on Windows. It's a dynamic library. And if you click on one module, there's a link, you click on it, you can actually browse the documentation, the API documentation of this module. So you have function name, description of every function, parameters, some example of code in Python or example in C++. Do you know Python? Who is good in Python? Please raise your hands. Python code. 1, 2, 3, not too much. What about C++? Please raise your hands. C++. Oh, yes, you can use Python. C++ is better. Okay, thank you. Yeah. Basically, if you want to program something running on the robot, you can use Python or you can use C++. You can also program the robot, but remotely in Java, MATLAB, and Java, MATLAB, .NET. .NET is C# so etc. And I think that's all. Okay, but this Java, MATLAB, .NET is only for remote programming. That means a program that runs on your computer and connects to the robot. If you want to have autonomous program running on the robot, you can only do it in Python or C++. Also choreograph file. But choreograph is mainly Python processes, Python script. So you can browse the documentation directly on the robot, but don't worry, you also have the documentation on your computer when you install the SDK. The next page is the package page. So this one lists all the packages installed into Linux. So the name, the version number, the website. So for those who are familiar with Linux, I'm sure you understand what I'm talking about. The next page is the memory page. So this one is quite useful for debugging. So we have a specific module which is called AL memory. So AL means Aldebaran library. Okay, so AL memory is one of our modules. I will show you again. It's here, it's called AL memory. So if you look into this module, you can see that there is a method like get data or insert data. So basically, AL memory is a dictionary. Okay, it's a dictionary where you can store pair of key values key values, and you can store that in a memory, and also you can subscribe to some events, some callbacks. You can subscribe callback on one key. So if the value change, then you are calling callback. So basically, the memory page here lets you browse into IL memory. So you can give a key, like for example ODID, and it will search in IL memory and list all the keys that match this. So here I just display my serial number of my robot.
Is that the way you get feedback?
So I don't understand the question.
Like we were monitoring to get feedback. Right?
Yes.
If we're coding, that's where we'd access. We subscribe to a whole bunch of different.
Some sensors are storing their value in IO memory. Some sensors no, but some yes. For example, foot bumper press. Left bumper press. So these two values, yes, is the when you press this, they are changed into IO. Of course, here it's a web page with static, so if I press it, nothing happens unless I difficult. Unless I update again. But do that, and you'll see the value change. So yes, this one is quite useful. You can store your own data. You can give any name. So if you make the behavior that stores some data, if you want to debug it, you can quickly go to the web page and see the status. The next page is the process page. So this one is the process running on the robot on Linux. So you can see that now she's running, for example, here. You can see that Python interpreter is running also. And you have some classical processing. The next pages is hardware. So in this page you have 4 tables that give you some information about the hardware. The first table lists all the boards, all the motor boards of the robot. So this is not very interesting, the version number, address, blah, 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 not very interesting. What is more interesting is these 2 columns. So you have ACK, is acknowledgement, and NAC, not acknowledgement. So basically it tells you if the motor board is connected, is responding. So normally you should have a lot of ACK and very few NAC. So if it's the opposite, then that means you have lost one motor board. In that case, you can try to reflash the motor boards. For that, it's very simple. You just need to press 5 seconds when you switch on the robot. You press until it becomes blue and it will flash the motor board. But probably you won't have this problem. The second table lists all the joints, so all the motor. And you have, for each motor, you have the temperature, the two angle. So one for the after the gearbox and one after directly on the motor. So these two values may be a little bit different for the bottom part, the bottom joint, but on the top there's only one MRE, like I told you, so the value are the same. You also have the stiffness ratio and the electric current in ampere, but here there is no stiffness, everything is zero. You can notice this one. This one is all zero. Why? Because this joint doesn't exist. It's a virtual one. You actually have only one joint, one motor to move like that. So if I move one leg, it moves the other leg. Okay? It's the same thing. So it's called left equal pitch. And the right equal pitch is then zero. But we have these joints, it's a kind of virtual joint, because if you want to make to program one leg and you want to make it symmetrical with the right leg, so you can use it. You can use this joint. But if you change this joint, it will actually change the left equal pitch. Yeah. The next table is some configuration number, it's also number and finally, the last table will be the temperature of the CPU. This time is the dual temperature, it's given by the CPU. So basically that's it for the download page. Do you have any questions? No? No questions?
What's the best way to detect that something in front of the robot? Sooner is one way, what's the other?
You can use the camera also. So
Is there anything choreographed for that?
not really, but after that it depends what you want to detect. If you want to detect someone, face, then you have the face detection. We already implemented. We also have the face recognition. Yesterday Eric told you about you need the network. Actually, it's not true. You have a little mistake. You can make a face recognition on the robot. We also provide it. So face, if you have object, if you learn the object, and we'll show you this afternoon how to learn object, then you show the object, you will recognize it also. So we provide some boxes for that. Easy to use. Now if you want to detect any kind of object, obstacle, yes, you use the sonar. Or you can use the camera if you see some kind of change in the brightness or something like that. What kind of object you want to detect?
It was more obstacle detection.
Obstacle, I suggest you the sonar. You want to navigate in the body of jumping before the chair. Yes, definitely. Time consuming, yes. Okay, so if there's no more question, yes.
If you carry a mobile phone is static, will it affect the balance or the other sensor?
So you want to attach a mobile phone on it, or in the back, you want to attach a mobile phone, yes. So in that case, I would suggest to use a USB, no, not USB, yeah, a USB Bluetooth dongle. So you can, actually here you have a USB port. So you can buy some quite cheap Bluetooth dongle that you can plug, and then you can connect to your mobile phone in Bluetooth. Probably. It would be the easiest way to connect the mobile phone with the device. Or you can try to connect Wi-Fi with your mobile phone, but maybe more complicated. However, we don't provide a Bluetooth driver for that. So that means when you buy your Bluetooth dongle, you should make sure that you have a Linux driver for it. Or when you buy it, maybe the supplier of the Bluetooth dongle provides some driver. You just need to make sure that it also has a driver for Linux, not only for Windows driver. That's what I mean. And then you have more implementation to do. The thing is, all engineers have successfully implemented Bluetooth dongle in Mouse head, but we had to remove it for a stupid reason. Because our robot is certified for the European certification and US certification. But when we certify it for the US, we only certify it for Wi-Fi and not for the Bluetooth. So if we put the Bluetooth in it, then we may lose the certification for the US, which impacts us on the selling the robot. So we decided to remove the Bluetooth, and we cannot give you this even if we have all the product. So only the user can implement it on their side. Maybe in a future version we will ask again for certification, US certification, of both Bluetooth and Wi-Fi. So, by the way, that's just to connect the phone, but any kind of other device will work also. And that's the dongle also. That's the dongle, and we are still working on it. It's not really. Any more questions? So before lunch, I will show you a little more of the documentation we have. That's the documentation for 114, but it's very similar to 112. The conversion to 112. So you have some very simple documentation and the step, blah, blah, blah. Some documentation about the software itself. So for example, monitor, this is basically what I explained to you, how to use it, the different buttons, etc. The choreograph, how to use it, etc. The NAO SIM. But NAO SIM, you will use the version 110 for NAO SIM because we have a lot of license issue. So maybe when you will install the documentation, or when you will install Choreograph 112, you have the documentation for NAO SIM 112. So the NAO SIM 112 have a little more features, but not too much more features. Now, Flasher is not very important. And you have more the programming side, so some kind of overview, how to program in C++, in Python, in Java, .NET, that will be this language. And it's a script language for robotic. I'm sure you don't know it. It's not very popular. And you have the API. So the API that I just showed you on the robot, you can also browse it on your computer, so you can click on the module again, like evaluation, this one is, it's the same API. No matter which language you use, you have the same function name, the same parameters, only the syntax change a little bit. But in C++, we also give you some information about how to program in C++. So basically, that's what we'll see for. And the same for Python if you want to program in Python. GBuild is a tool for cross-compiling, tool that we have developed for cross-compiling. It's a tool written in Python. Because our engineers in France, they really love Python. Python everywhere. So basically, this one is to it's a command line tool to compile your project on different platforms, on Windows or on Linux. If you want to compile it for the OS. You can install it. I'm not convinced by GBuild personally. I don't think it's very great. But if you have a share folder between, imagine you have a GBuild on your PC, Windows, Linux, and you want to share a folder, and you want to put your source code here, so that you can build this source code, the same source code in Windows, or build the same source code in Linux. Then okay, maybe you can find some interest in GBuild. But in my opinion, it's one. There's also some good, not really tutorial, but example or explanation on different parts of the robot, for example, on motion. Just hardware reference. We have also some inverse kinematic we have some inverse kinematic in NAO. You know what is inverse kinematic? You just you point in space, and then now we try to move this arm as it is to reach that position in space. So basically you for example, with this point, and it will compute exactly which angle of the whole articulation to reach this point, right? So that's very useful, because if you want now to capture an object, once you know the position of the object in the world related to the position of the object, you can just use the inverse kinematic to say go there, and you will try to solve the angle position to go there. But the difficult part, of course, is to locate the object in the world. So, of course, usually we use the camera for that. The sonar is not precise enough. Okay, so there is some example about this. And we have some kind of demo like that. So show you the demo. Just try to go here and give this balance. So this is just in the API. You can use that in the API. But in my opinion, it's quite useless, except for this demo. It's quite impressive, but it's quite useless. But what is more useful is the invest in Latin, which is a bit similar API. It's working with the same. Because basically here is trying to control the head position.
Statements removed. Statements removed.
So yes, the documentation is quite good, I would say. There's a lot of documentation inside. You should not hesitate to browse it, to look inside, and you may find what you are searching. It's not only API. We have the API description, every function and parameters, but we also have some example and some tutorial and some global explanation about that. So you can really go. Any questions before we go to lunch? No? So maybe we'll have lunch, and this afternoon I will explain the choreograph. I will show you choreograph. What time do we start again? Past one? Okay. So past one. Thank you.
The lunch is served for them. And the whole look around, and you can see there are not many competitors. Half of you will be